Yes, thanks for the introduction, and hello again. I will give some insights into our SANE research titled Evaluating Spatial Consistency Across Loudspeaker Configurations and Rendering Tools. And besides me, this research is also with Felix, as well as Matthias Frank, Lukas Gölles, and Franz Zotter from the IEM in Graz. Yes, so let's start. As we've seen it in the past days, spatial audio is currently shaping one of the main trajectories in the music industry. And while the format encompasses advanced methods in order to spatially distribute sound, it leverages both audiences and artists and new forms of creative expression and auditory experiences. And for artists hereby a novel dimension of composition is introduced, providing a sophisticated framework for them to sculpt and arrange sound in space. And alongside these increased options that they have, unfolds quite a diverse landscape of sophisticated audio technologies and freely accessible software products in order to meet these emerging demands. For audiences, on the other hand, it allows new forms of collective experiences. Specialized venues are popping up more and more in order to showcase the immersive works that are produced. And nevertheless, this technological shift brings forward a quite critical challenge, which is sustainability. And for spatial audio to truly flourish, artists need to be able to tour through Europe's venues in order to overcome the physical limitations, and not just Europe's, of course, global venues, in order to overcome the limitations of physical spaces. And besides the aspects of compatibility hereby, there's a question at the heart of the composition being raised, which is how can we preserve the spatial intent across different venues with eventually different room acoustical properties or different loudspeaker configurations, or even different rendering algorithms being employed. And while traditional stereo setups always faced difficulties in this already, this becomes way more dramatical in terms of 3D audio, because here the physical space becomes more relevant in terms of sound distribution. And configurations can hereby shift between very high density loudspeaker arrays up to very sparse overhead arrangements without loudspeakers at the ceiling. And the Spatial Audio Network Europe is here a collaborative initiative to foster artistic residencies across Europe. And those are then able to create artistic works that one can, on the one hand, experience live at the place, or ideally also streamed between the connected venues in the network. And as the same project therefore tries to establish a streaming infrastructure and to connect these multiple venues, it becomes very important to preserve this artistic intent in order to assure that the artist's intention reach the audience. And the presented research for today therefore depicts pilot research within the network in which we try to evaluate speaker configurations and loudspeaker rendering and rendering algorithms. And the aim is hereby not to do a linear mapping function, but to establish a general understanding of what's the relationships between these in order to apply them in practice. And for this, I'll go through our underlying motivations first, then go into our methodological approach, then share some initial findings and discuss them, and at the end give a little outlook into where this could go. So when it comes to streaming, there are a few options. A quite resource-friendly approach is to stream the discrete decoded audio channels along with their coordinates, and then the transmitting venue, quite straightforward, can reinterpret those as virtual sources and re-encode them by a rendering algorithm of choice. And this brings a high degree of simplicity and quite reduces the network load, since we don't need to send metadata along with the audio, and the number of streamed channels is usually constrained to our sound system, which means that we eventually, just like here, we would have to stream 32 channels, which is quite cheap, I would say. And this becomes particularly practical in terms of diffuse sound. So if we have spatial reverb, or if we have, I don't know, granular synthesis where we have a lot of sources, then this kind of scene-based representation puts all of them in one. But as it avoids the complexity, it also introduces some rendering-dependent inconsistencies, because we don't know what's the receiving venue using in terms of decoding or re-encoding. This could be VBUB, ambisonics, or proprietary software. And the flexibility trade-off also has the price of we basically collapse the object-based representation into a scene-based one, which means that we have a fixed spatial image, and we cannot pre-process that afterwards, which might be quite useful. And in addition, the transmitting venue sound system basically defines the spatial resolution, because if we have a sparse array that we stream, then that's a sparse resolution that we provide. And furthermore, these approaches become increasingly impractical if we try to, or if the streaming venue operates a high-density loudspeaker array or wave field synthesis, where the sheer number of channels or the physical underlying concept even make the transmission and reinterpretation of these signals complex or even infeasible. And therefore, we could foster the rendering choice, for instance, by encoding the channels already into ambisonics. Yeah, it's another solution. We don't need to provide the loudspeaker coordinates, which is also a benefit. And we also avoid that they are misinterpreted, as for instance, sides are being flipped, or coordinates just ending up somewhere where they should not be. But yeah, one of the main downsides is that it shifts the processing load to the transmitting venue, which might already be resource constrained, to the concert that it's operating and the streaming. And we would likely end up with more channels, because we want to stream a high resolution, and usually, therefore, we want more than 32 channels, for example. So this is not quite a good option. Furthermore, it's also dependent on the playback system at the receiving end, because we know ambisonics has some kind of spherical dependencies. Yeah. And an alternative, therefore, could be to already take the sources and encode those into the ambisonics domain. And one key advantage is that we have a high resolution, format agnostic format that we can just provide. Most venues can just use that and encode it, decode it to their loudspeaker array. But one of the key downsides is that it, from the very beginning, ties the spatialization process to ambisonics. And we know that there are a lot of great pieces in software that are not employing ambisonics, so that's also not such a good option. And that brings us to the final, most flexible one. Of course, there are also other solutions, but that is to stream the audio objects along with the metadata, which can, for example, be done with the audio definition model, which we had this morning. And yeah, that's the most flexible. But it comes at the price that we have quite a large number of sources, probably, or in some compositions at least. And especially with diffuse signals, that's eventually not a good way to go. Yeah, because the channel and metadata load can become quite a bottleneck. And it requires additionally a stable infrastructure on both ends that is synchronized, and that is a bit of an effort. But nevertheless, it provides a good flexibility. So we can sum up that the streaming of sources with metadata offers the largest flexibility, but also comes at the price of the largest perceptual uncertainties, while the discrete decoded channels seem to offer quite a good trade-off in terms of perceptual quality and feasibility or simplicity. So what we did is to do a first listening experiment or pilot test in which we compared two rendering algorithms with 3 different speaker configurations and 2 concert venues. And therefore, let's start with the compared rendering algorithms. For that, we used ambisonics, which we implemented with the IEM plugin suite, and vector-based amplitude panning. And ambisonics should now be thoroughly demystified, I think. But for those who were not here yesterday, it's basically a format to encode a sound scene into an intermediate state and then decode it to an arbitrary loudspeaker array. And on the other hand, VBAP calculates directional vectors between triplets of loudspeakers and then assigns gain values in order to create phantom sources. And in terms of the performance environment, again, the colors are a little bit odd, but yeah. We have compared the IEM Cube, which is the beautiful sound system at the IEM in Graz, as well as this room here. And at the IEM Cube, we have around 120 square meters, here 160, and both rooms have an average acoustic treatment. Then the second condition, or third condition, was the speaker configuration. Here, we on the one hand, or we basically took subsets within the given speaker layouts. So on the one hand, we took a full spherical representation, so all the channels available, which are 25 at the IEM Cube and 32 here in Graz, in Leipzig. And yeah, the second one was a 7.04, which is basically a normalized standard. And we tried to match the speakers that would most likely fit this format. And the third was a ring of 8 loudspeakers. And we can see that the ring of 8 of the IEM Cube is blue. And this is because here we have approximately point source loudspeakers, so very classical loudspeakers. And at the IEM Cube, they employ line array loudspeakers. And the benefit usually is that if we double the distance from a loudspeaker, then we have 6 dB decay. And with the line arrays, that's just 3 dB as far as I know. Yeah, and that brings benefits. So based on those, we took a look at those perceptual variables, which are the localization, which is describing the accuracy of perceiving a sound source at a position or specific directions. Then continuity, which describes the smoothness and spatial coherence of trajectories. The envelopment, so listening envelopment, which means the sense of being physically surrounded by sound. And the listening engulfment, which describes the sense of being physically covered by sound. And last was the mixed balance, which basically describes a preservation of the level ratios between different positions. Yeah, based on this, we conducted a Murchra-style test, which I think is not so relevant here, but yeah, we tested 2 listening positions, once at the sweet spot and once half the radius in order to cover a large listening area or to see how these effects vary. Yeah. Overall, we had 30 participants. 16 of them were here at ZIMT and 13 participated in Graz. And basically, the people were placed in the middle of the room with a table, and they had a graphical user interface in order to interact with this custom graphical user interface, which enabled them to switch between the individual conditions in order to right away compare them with each other. And then they could just, based on this, use a slider in order to rate the perceptual attribute. So for each of the 5 attributes, 1 page was dedicated with all of the 6 conditions. And here I quickly describe the test signals that we used. So for localizability, we had a frontally panned Meyer speech sample. Continuity was tested with a pink noise that was rotated across the horizontal plane over a duration of 8 seconds. Listener envelopment was used with 8 equidistantly spaced pink noise sources. And the listener engulfment used 8, or the same configuration, just elevated to the ceiling by 45 degrees. And the mix value used tracks from a musical piece that were penned to minus and plus 90 degrees and 1 frontally. And I'll try to keep the statistics simple because I think lunch is still being digested. So this brings us to the results. I'll start with the localizability or localization. And what we can see here is the individual renderers, which we compared, ambience but Gris. And up here we have the loudspeaker configurations. And this we did once for the IM cube and the Zimthal, and that's how the next slides will look like. So looking at the IM cube, we could see that both the renderer and the layout had an effect on the localizability. At the IM cube, we could see that VBAP quite strongly outperformed ambisonics. And this is the case since the virtual loudspeaker positions, or source positions, were placed directly on the loudspeaker positions. And therefore, just a single loudspeaker was active, which means that we get the sound right away from that direction. And as we can see here on the right side, the line array even further improved that, which is because we get a better direct to reverberant ratio and therefore more spatial clarity. And that's why the performance seems better. Ambisonics, no, the Zimt, in the Zimt renderer, we could see especially an effect at the center position, again from the renderer and the layout. And here, conversely, the ambisonics performed better, and that was because the virtual sources were positioned between the loudspeaker positions, which means that we have more than one active loudspeaker. And at the end, it seemed like that made a difference. For the ring of 8, which was the second ring, so the one at ear level, we can see the other way around. And here again, we have positions obviously on the physical loudspeakers, and this shows that the advantage of VBAP for precise localization especially comes about if the source is matching the physical loudspeaker. Continuity, on the other hand, shows a significant main effect of the renderer quite strongly. We see it very sharply going down in terms of VBAP, and this is because the number of active loudspeakers is more strongly fluctuating, which means that we have more timbral coloration and just a more bumpy image. And this can be observed throughout all of the conditions, irrespective also of the listening position. The listen envelopment further shows that there's not an effect of the renderer, but we could see an effect of the loudspeaker layout. Hereby, and this is especially because we would imagine that the sound sources are all rendered with an equal loudness. Like there's no reason for the one noise being louder than the other, which makes them rendering independent. The layouts at the IM cube showed for the sparse the worst performance, and for the line arrays we could see the best performance. And again, this is because we have a better loudness balance, which is comprised for the point source loudspeakers. And that again shows that the line arrays quite increase the perceived listening area. In terms of engulfment, which is the coverage of sound, so quite similar to the last attribute, we could see the same effect. It depends on the rendering, but not at the layout. Not on the rendering, but on the layout for all the tested conditions. And at the IM cube, we could see a clearly decreasing number with the loudspeakers to down here. And it's pretty much worst for the 8 line array loudspeakers. While at the Zimthal, we could see that the sparse grid performs a little less good than the other ones. And here the line array and the full spherical array show comparably good results. And this is the case because the loudspeakers that are, for example, employed here in these two configurations are higher than the line array loudspeakers. And also here we could see that the sparse grid employs the bottom loudspeakers, while these two grids have the elevated ring, and that means that we just managed to bring the sound further up into the room. And that brings us to the last perceptual attribute, which is the mix balance. And here we could see that for all the conditions, there was no effect of the loudspeaker layout except for the off-center location at the IEM cube, which would be this one here with a square. And we could see that it quite increases with a decreasing number of loudspeakers. And it even gets best, again, for the line array loudspeakers at the horizon, which is, again, the loudness not being reduced. And in most conditions hereby, we could see that the mix balance is not clearly depending on the renderer. So here we don't have an effect on all of them. And again, there's not really an inherent reason why the sources would be rendered with a different volume. So we also assume that the effect stays the same. But if we go to the off-center, then we could see some effects occurring. So I'll try to sum it up a little bit. The study tried to investigate three loudspeaker configurations, 2 panning algorithms, 2 listening positions, and 2 venues. And hereby the results of both venues have showed quite similar results. So IEM Cube and Zimt Hall have shown quite similar results. And the localizability, so the first one showed a dependency of the rendering method, especially with VBAP being more accurate, but only for sources that were matching the actual loudspeaker positions. And we could see that the effects basically vanished when we were positioning them in between loudspeakers. And I think, as Daniel also yesterday assumed it, that was almost correct, but somehow the effect of sources in between and more loudspeakers being active in VBAP kind of eliminates those effects a little bit. Continuity, on the other hand, showed the best result for ambisonics, which was to be expected because it's just a bit more smooth in terms of loudspeaker distribution. And the other 3 effects were not depending on the renderer per se. But envelopment, of course, benefited from loudspeakers being elevated, even more than ear height. The engulfment benefited of this. Yeah. And yeah, we could see that the mix balance, especially at the off-center, benefited by using these line array loudspeakers. So I think the main takeaways hereby are that if they are available, it makes sense to eventually employ these loudspeakers because they just increase the listening area. Most people will have more fun during the concert, and that loudspeakers should be elevated at least over 30 degrees. So there should be some at the top, ideally, in order to provide this kind of coverage. And if we think about localization, it's a bit dependent what we try to aim on, if it should be moving sources or stable sources. And in terms of continuity, ambisonic seems to be the winner, to say. Yeah. So a bit of outlook. First of all, it's to say that these results have to be considered within the limitations of the listening experiment. So we just conducted them in 2 venues. It would be smart to use maybe larger scale venues, scale different loudspeaker arrays in this in order to get a bit more of an understanding of how these results are generalizable. And also in terms of the loudspeakers that we used, they have certain directivities, they have certain
equalization, and these all are factors that could shift these results into a different corner when being compared to other methods. But one primary goal for future experiments would be to compare directly the rendering methods that I was showing in the beginning. For example, to play back the same composition and material using a direct channel decoding or encoding the direct channels of another venue into our venue, for example, in comparison to streaming the metadata and re-encoding the whole thing here. Probably there's also the matter of question what resolution we do this in, and yeah. And one other solution, for example, that we thought of for streaming audio could be, because we have a difficulty with diffuse sounds like spatial reverb or a lot of sources, and we also talked about it yesterday a little bit, that it would be interesting to find a solution in order to stream object-based audio but still have these diffuse components somehow being transmitted without an exploding network load. And a hybrid idea could, for example, also be to stream the direct sources with the metadata, and on the other hand stream the diffuse signals by some kind of scene-based representation. Of course, for the rendering engines, this would mean that we need to adapt all the processes. For DSound would have to build some kind of extra routing there or so. But it could be an idea in order to think about future ways of streaming audio in order to really preserve the spatial characteristics of the compositions. And therefore, I think it would be interesting also to compare reverberation in different scenarios to see what's the results. And that was the first research we did.